Number 6. First of all, before I start number 6, I notice there's a whole lot going on in number 6. We're given a table and a graph and an equation. We're not going to let that stop us. We're just going to take little pieces at a time, and you're going to do just fine. Okay, so number 6 says to let f be the function defined by f of x equals cosine x 2x, cosine of 2x plus e to the sine x. Let g be a differentiable function. The table above gives g and its derivative, g prime at selected values of x. And then let h be the function whose graph consisting of fine line segments is shown in the figure above. So part A, so we're not going to try to look at it all at one time. We're just going to piece it by whatever they tell me to find. Okay, part A asks me to find the slope of the tangent line to the graph of f at x equals pi. So if they ask me, they didn't say an equation of the line, just the slope. We know that the slope is a derivative, and we're finding the derivative of f. So they actually are asking me to find f prime of pi. So the first thing that I want to do is take f. I'm going to take the derivative of that. I'm just going to rewrite this a little bit. This actually would be cosine of u plus e to the u. So for each one, we know the derivative of cosine is going to be negative sine of u times the du, and then plus the derivative of e to the u is e to the u times du. So then from here, I'm not going to put that equal sign just in case I don't like it. I'm going to put my u back in for each of them. So negative sine of 2x times the du, the derivative of 2x is 2, plus e to the sine x times the derivative of sine x is cosine x. All right, so I have f prime. That is what f prime equals. Now from here, I want to evaluate it at pi. So negative sine of 2 pi times 2 plus e to the sine of pi times cosine pi. Now please remember, it is a non-calculator problem. It's a free response problem. If I left my answer like this, they would have to give me full points for it. I am going to go ahead and reduce it. The sine of 2 pi is 0. Sine of pi is 0. Cosine of pi is negative 1. So this is going to be 0 plus e to the 0 is 1 times negative 1 is negative 1. And so f prime of pi is equal to negative 1. But again, if I left my answer like this, they would give me full credit. I got 1 point for finding the derivative, the general derivative, and then I get 1 point for finding that other answer. Notice we didn't use any other parts of the problem. That's okay. Right, part B, this time we're talking about k. K of x is equal to h of f of x, and it asks us to find k prime of pi. Well, I notice that this is a composite function, and I see parentheses. So I'm going to rewrite k as h of u, because the stuff inside we're going to call u. So if I take the derivative of that, I'm going to get h prime of u times du. Well, what's the derivative of u? The derivative of f of x is f prime of x, okay? Now I'm going to put everything back in terms of x, and now I can start using my equal sign. You'll notice when I was using u's, I did not put an equal sign because I didn't really ever establish what that was. So I'm just going to put my equal sign when I'm back to all x's. So I'm going to put h prime, u was f of x, and then times f prime of x. Okay, now that I have my general derivative, I'm ready to plug in pi. So I'm going to get h prime of f of pi times f prime of pi. All right, so here we go. I'm going to now get h prime. To get f of pi, I'm going to come up into this formula and plug pi in for my x. Okay, the cosine of 2 pi is equal to 1. Sine of pi is equal to 0. E to the 0 is 1, so 1 plus 1 is 2. So f of pi is 2. And then times f prime of pi, we found that in part A, that was equal to negative 1. Okay, and now I'm still not done. H prime of 2, if I look, here's the h graph, h prime at 2, it's this point right here. H prime, if this is h prime is the slope, and if you look at the slope of this line, it goes down 1 over 3. So the slope of this right here is going to be negative 1/3 times negative 1, which is 1/3. Okay, we would get 2 points for this part. We're going to get 1 point for getting the formula for the general derivative, and then we get 1 point for getting that right answer. All right, part C. Now we're going to M. Great. let m be the function defined by g of negative 2x times h of x. So now all of a sudden I notice this times in here. To me, that's definitely going to tell me I'm going to have to use the product rule and then find m prime of 2. So one thing I'm going to do here, notice that g is not just an x, there's something there, so I'm going to put u. So I'm going to redefine that as g of u. So if I'm finding m, the derivative of, I'm going to, just a second here. I'm going to have to come over here and do the product rule. This is going to get a little bit messy, so hang with me. Okay, so to get f prime, I'm going to leave myself a little more space. To get the derivative of g of u, it's going to be g prime of u times du. The derivative of negative 2x is negative 2. So if I rewrite that, g prime, u was negative 2x times negative 2. So that is my f prime. G prime, the derivative of h of x is h prime of x. All right, so I'm ready to use a product rule. So m prime of x is equal to, I'm all back to x's, that's why I'm going to go ahead and use my equal sign here. I'm going to have f prime times g. So I'm going to have g prime of negative 2x times negative 2 times, so that was f prime times g, which is h of x, plus f, which is g of negative 2x, times g prime, which is h prime of x. Boy, that got really messy. Okay, so that's my general derivative. I now would like to evaluate it at 2. So now I'm going to get g prime, if I plug 2 in there, I'm going to get g prime of negative 4 times negative 2 times h of 2 plus g of, if I plug 2 in there again, I'm going to get negative 4 times h prime of 2. Okay, now it's just going up here. Let's see if we can figure stuff out. And I'm going to go above here in this extra space here. Okay, g prime of negative 4. G prime of negative 4 is right here. It's negative 1. So I'm going to get negative 1 times negative 2 times h of 2. Here's h right there. H of 2. This is h. So I'm just looking for where's that at. This would be down 1/3. This would be down another third. So that's going to be negative 2/3. And then plus g of negative 4. Go up to my chart. G of negative 4 is 5 times h prime of 2. We already established that h prime of 2 is equal to negative 1/3. Okay, you don't like these fractions, you can leave your answer right there. I am going to clean it up because that's what I like to do, but don't feel like you have to. So I'm going to end up getting negative 4/3 minus 5/3, and that's going to end up equaling negative 9/3, which is negative 3. So I just found that m prime of 2 is equal to negative 3. But again, if you want to leave your answer long and messy, go for it. Okay, I got 2 points for that one, I believe. I'm going to get 1 point for getting that general form of the derivative, and then 1 point for getting that final correct answer. Okay, part D. Is there a number c in the closed interval negative 5 to negative 3 such that g prime of c is equal to negative 4? So we're using this chart right here to help me out. Okay, I notice they're giving me an interval and then they're giving me a derivative. In my mind, that should be bringing up the mean value theorem, which says something about the average rate of change equaling the instantaneous rate of change. So if I can show that the average rate of change between these two x values is equal to negative 4, then the mean value theorem will be verified. So I am going to go ahead, I'm going to plug in negative 5. So I'm going to do g of negative 3 minus g of negative 5 over, just using the slope formula here, negative 3 minus negative 5. If I look up g of negative 3, I get g of negative 3 is 2 minus g of negative 5 is 10 over negative 3. That's going to turn into plus 5. That's going to give me negative 8 over 2, which does equal, and I can put equals between because these are all equal statements, is equal to negative 4. So I have just found that the average rate of change is negative 4, so we know by the mean value theorem that it is also that. So we got to set up our conditions. I'm going to say, since g is differentiable, because they told me that g is differentiable, and remember, we also have to say continuous, which also means it must be continuous. So you have to mention differentiable and continuous. since G is differentiable, then by the mean value theorem, sorry, it's getting a little sloppy here, there must be a value C in the interval -5 to -3 such that G prime of C is equal to -4. I don't need to mention this part up here because I've already shown a lot of nice work for it. So since G is differentiable, which also means it must be continuous, then by the mean value theorem, there must be a value C in the interval from -5 to -3 such that the derivative is equal to -4. Okay, we're going to get 2 points for that. If I found that average rate of change, I'm going to get 1 point for it. And then if I was able to justify my answer, I get that last point. And then I think I covered everything. Did I get all my points for that? 2, 3, 4, 5, 6. Oh, on the last part, just an FYI, on part C, I actually got 2 points for this part right here. So if you made a mistake in one of the parts, you would have gotten a point instead of 2 points. But just wanted to say that. But then otherwise, I believe 6 is corrected.